All right, guys, so last week we started our discussion of rational functions, and we talked about how we find the domain of a rational function, and I went through a couple of examples of doing just that. We saw that it basically involved looking at the denominator of your rational function and letting it equal to 0, and then solving with the resulting equation. Today I'm going to look at something different. I'm going to look at finding the x and y intercepts of a rational function, and then next week I will sort of wrap it up and we'll see how we go about graphing essentially a rational function. Okay, so I'm going to take questions 1, 3, 5, and 7 again. You see it right here. A of x is 2x squared minus 9 over x squared minus 9. And so again, what I'm looking for today is the x and y intercepts. I have a function here that potentially at least crosses the x and y intercepts. And this already has x and y intercepts. And what I want to do is I want to find those values. Okay, so how do I start this? Well, in order to find the x-intercepts of really any function, what I'm going to do is I'm going to let that function equal to 0 and solve, right? So what I'm going to do is I'm going to essentially let this equal to 0 and then solve it. That's all that's involved in finding essentially the x-intercepts of any function. So if I ask myself, I have 2x squared minus 9 all over x squared minus 9. If I let that equal to 0, well, when is that function a of x equal to 0? Well, it's equal to 0 when its numerator is equal to 0. It's equal to 0 when 2x squared minus 9 is equal to 0. And so when I have a rational function like this, all you actually have to do is let your numerator equal to 0 and solve. And any values of x that would have your numerator equal to 0, those are the values of x that you're looking for. So that's what we're going to do here. So I'm going to let a of x equal to 0 and solve. That's all I'm going to do. So 2x squared minus 9 all over x squared minus 9 is equal to 0, and therefore 2x squared minus 9 must be equal to 0. So 2x squared minus 9 is equal to 0. I just have to solve for x, and I'm sure none of you have too much difficulty doing that. What I'm going to do, I'm just going to add 9 to both sides, so I will have 2x squared is therefore equal to 9, and therefore x squared dividing both sides by 2 is equal to 9 over 2. And then I have an x squared on the left. I'm going to take the square root of both sides. It follows that x is equal to, I'm taking the square root of 9 over 2. I must take plus or minus, of course, when I'm taking the square root of 9 over 2. The square root of 9 over 2 is the square root of 9 all over the square root of 2. And the square root of 9 is 3, so this is plus or minus 3 over root 2. Plus or minus 3 over root 2. Now, oftentimes we don't like to leave a radical root 2 in the denominator. So what you can do here, if you like, is you can multiply this with a different color. You can multiply above and below by root 2 over root 2. Okay, that will get rid of that radical underneath in your denominator. And so I will have 3 root 2 up on top, and root 2 times root 2, well, root 2 times root 2 is root 2 squared, and root 2 squared is 2. And so that is 3 root 2 over 2, and of course, can't forget plus minus right there, right? Because I took that square root. And so your x-intercepts, you have 2 of them. 2 x-intercepts. x1, call it x1, is negative 3 root 2 all over 2, and x2 is positive, plus sign, 3 root 2 over 2. Those are your two x-intercepts for this given function. All right, so that's finding the x-intercepts. I'm going to take my time with the first one, but as you'll see, as we go through them, I'm going to go through a little bit faster. In order to find the y-intercept, what I'm going to do is I'm just going to delete this. So I want to find the y-intercept. Okay, so this time that was the x-intercept. This is the y-intercept. Well, what is the y-intercept? It is the value of the function when x is 0. So essentially, the y-intercept is a of 0. It is the value of the function when x is 0. The x-intercept is the values of x for which the function is 0. This time it's the value of the function when x is equal to 0. So all I'm going to do is I'm going to find a of 0. And of course, this doesn't just apply to rational functions. This is just how we would go about finding the y-intercept of any given function. So I want the y-intercept, I want a of 0. Well, what is a of 0? A of 0 is going to be 2 times 0 squared minus 9 all over 0 squared minus 9. I'm just inputting a 0 everywhere I have an x and going through the algebra. 0 squared is 0. 2 times 0 is 0. So up on top I have 0 minus 9. And down below I have 0 squared, that's 0 minus 9. I have 0 minus 9, well that's negative 9. Divided by negative 9. A minus over a minus is a plus. 9 over 9 is 1. And so my y-intercept is 1, and as an ordered pair, of course, therefore, it is 0, 1. That's my y-intercept, 0, 1. And that's how you go about finding it. That is your y-intercept in this particular case. All right, so that's it. That's how you go about finding the x and y-intercept for a function. Let me go through a few more so that you get the hang of it. All right, so question number 3, I have c of x is x plus 3 over x minus 2. Again, I want to find the x-intercept to start. X-intercept, I'm just going to let my function equal to 0. What does that mean? It means that my numerator, x plus 3, is equal to 0. X plus 3 is equal to 0. I don't have to worry about the denominator, just the numerator. X plus 3 is equal to 0. Well, solving this, very straightforward. X plus 3 is equal to 0. Well, therefore, x is equal to negative 3. X is equal to negative 3. And so my x-intercept, I only have one this time. It's negative 3, 0. That's it. Negative 3, 0 is my x-intercept. And again, I only have one in this for this particular rational function. So negative 3, 0 is my x-intercept. My y-intercept, I'm going to find c. My function this time is c, so I have c of x. I'm going to find c of 0. Well, c of 0 is therefore going to be inputting a 0 everywhere I have an x. That is 0 plus 3, all over 0 minus 2. 0 plus 3 is 3. 0 minus 2 is minus 2. That is negative 3 over 2, or negative 1.5, negative 1.5. And therefore, my y-intercept is 0, negative 3 over 2. You can just leave it as an improper fraction like that, negative 3 over 2. And those are your two values. It's your x-intercept. This time you only have one. And here's your y-intercept, negative 3 over 2. Okay, that's C. Moving on, E of x. All right, so this time, remember this problem from last week. I have essentially a quadratic in my numerator, but it's already been factored for me, so it's nice. So I have 2x minus 1 over x plus 2. Again, I'm going to let my function equal to 0 in order to find that x-intercept. That's what you're doing. You're letting it equal to 0 in order to find that x-intercept, but that just means that your numerator is equal to 0. So I have 2x minus 1 times x plus 2. That's what's going to be equal to 0. So solving this, well, I could just take them one at a time. 2x minus 1, the value 2x minus 1 multiplied by the value x plus 2, if you multiply those two together, you take their product, it's equal to 0, then one or both of them must be 0. So 2x minus 1 is equal to 0. Well, if 2x minus 1 is equal to 0, it follows that 2x is equal to 1, and therefore that x is equal to 1 over 2. X is equal to a half. That's one value of x. So that's one solution. And here I have x plus 2. It's my other factor. You let your other factor equal to 0. X plus 2 is equal to 0. And therefore x is equal to minus 2. And that's your other solution. X equals minus 2. And so I have two x-intercepts. One of them, let me scroll down. One of them is 1/2, comma 0. That's one x-intercept. And the other one is -2, comma 0. So again, much like in the first problem, this time we happen to have two x-intercepts. So 1/2, comma 0, and -2, comma 0. My y-intercept, I'm going to find e of 0. I'm going to put in a 0 everywhere I have an x. So what is that going to give me? It's going to give me 2 times 0 minus 1, 2 times 0 minus 1, parentheses around that, times 0 plus 2, right there, all over 2x plus 3 becomes 2 times 0 plus 3, parentheses around all of that, times 3 times 0 minus 4. 3 times 0 minus 4. And again, parentheses all around that. And so what have I got? It gives me 2 times 0 is 0. Up on top, 2 times 0 is 0. Minus 1 times 0 plus 2. 2 times, in my denominator, 2 times 0 is 0 plus 3 times 0 minus 4. So that's what I have. But what does that give me? 0 minus 1. I have -1 up on top. -1 times 0 plus 2 is 2. And downstairs, I have 0 plus 3. That's 3. Times 0 minus 4. That is -4. I have my numerator then is -1 times 2. That's -2. 3 times -4 is -12. -1 times 2 is -2. 3 times -4 is -12. I have a negative above and below. Those will cancel. I have 2 over 12. That's the same as 1 over 6. And so that is my y-intercept as an ordered pair. That is 0, 1/6. 0, 1 over 6. That is your y-intercept. All right, that's that problem completed. Last one. Again, x-intercept. You know the deal by now. What I'm going to do is I'm going to let g of x equal to 0. That means I'm going to let x squared minus 4, just the numerator, equal to 0 and solve. Well, if x squared minus 4 is equal to 0, x squared is therefore equal to 4, adding 4 to both sides and taking the square root. I have that x is equal to plus or minus, forget that, the square root of 4 is 2. So I have plus or minus 2. And so, nice and straightforward, my two solutions are -2, 0, that's one x-intercept, and my other x-intercept is 2, 0. Those are my two values for x. Y, what am I going to do? I'm going to find g of 0. Just remind myself what the letter they're using is. G of 0. So I have x squared minus 4 becomes 0 squared minus 4. That's my numerator. And I have 3 times 0 squared plus 0 minus 4. 0 everywhere I have an x. Up on top, 0 squared is 0. Take away 4. Well, that leaves me at -4. That's my numerator. And And downstairs, 3 times 0 squared is going to be 0 plus 0. I still am at 0. Take away 4, I'm at minus 4. So I have minus 4 in my numerator, minus 4 in my denominator. That is 1. Minus over minus gives me plus 4 is 1. And so my y-intercept is excuse me, almost wrote 1, 0. It is 0, comma 1. That is my y-intercept. And that is how we go about finding the x and y intercepts of these problems. So I leave you to try 2, 4, 6, and 8 for yourself. It's the exact same thing. So it's not too difficult, but it is very important that you understand how to do these things. How you find the x and y intercepts of any function. Typically, rational functions are functions that students have most difficulty with, and there are some challenging aspects to graphing rational functions that we will talk about in future videos. But just for today, finding those x and y intercepts is a good start so that you can start to get a sense of perhaps what your function is going to look like, or after you've graphed it, the points to look for. And a way of checking to make sure that you have in fact graphed it correctly maybe would be to see, well, have I found the x and y intercepts correctly? Have I found the correct number of x-intercepts, for example? Okay, so that's it. I leave you to do the remainder, and I will talk to you again soon.